All right, last video. We are going to tie all those transformations together. So technically when you're doing them, like if you were doing these as transformations, you would stretch it or you do your narrowing and your widening and you're putting it over top of or opening it up or down first, and then you would look at the vertex, but we're going to graph them opposite. But I'm still going to talk about what the A does, what the H does, and what the K does. So when A is positive, the parabola will open up. The vertex is a minimum, and this will matter next class. When A is negative, the parabola will open down, right? So this is smiley face, this is frowny face, and the vertex will be a maximum. When the A is greater than 1, the graph will be narrower. It is vertically stretched. When the A value is between 0 and 1, the graph is wider. It's going to be vertically compressed or shrunk. And then moving on to the H and the H determines the X value of the vertex, and it's always opposite as it appears, and the K is the Y value of the vertex. And then your axis of symmetry is always X is equal to H. So now what we're going to do is we're just going to graph a whole bunch where you can have A, H, and K. Sometimes no H, sometimes no K, sometimes no A. It'll be different combinations. So let's look at this one. For this one, what have they given us? Well, think about the equation. Y equals A x minus h all squared plus k. If you look at this one, if I was to put this one in that form, it would be y equals 2, and then there's nothing in the bracket with the x. So there is no h value with this one. What does that mean? Well, if you look at this one, the vertex will be 0, -3. The axis of symmetry will be x is equal to 0. And that's all you really need. If you can look at that equation and be like, oh, the vertex is 0, -3, everything else can come from a table of values. So vertex is where your graph always starts. This graph is going to start at 0, -3. Now, if you're ready for it, you could look at this 2 and see that because it's positive, my graph is going to open up. And because it's a value greater than 1, the graph is going to be narrower. If not, what I want you to do is to draw a table of values. Table of values is not mandatory. And you're going to put your vertex in the middle. And then you're going to do 2x values down from there and 2x values up from there, always. And then you could plug in the value of x and solve for y. So if we plug in x is 1, we would get 1 squared times 2 is 2, minus 3 is -1. So I've got a point at 0, -3, and then I've got a point at 1, -1. Thinking about this 2, that means that from the vertex, I went over 1, and instead of up 1, I went up 2. So if you don't need the table of values, if you can see that, you can skip the table of values altogether, right? So what does that mean? It means that if I was to do another point, normally I'd go over 2 and up 4. Because there's that a value of 2, I'm going to go over 2 and up 8. If you're okay with that, skip the table of values. If you're not, put in your value of x. When x is 2, what will y be? Well, 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. I get a point at 2, 5. So it'll do the same job. Then, even if you are a table of values person, maybe you recognize that you only need half the table of values, right? I can mirror these points over. Or maybe you just have real trust issues and you just want to be like, I just want to plug it in, Karen. So you could plug in 2 times -1 squared minus 3. You can do it in your head. -1 squared is 1, times 2 is 2, minus 3 is -1. Oh, look, I have a point at -1, -1. From the vertex, I went over 1. Instead of up 1, I went up 2. Then I'd go over 2, and instead of up 4, I'd go up 8. Or if you have trust issues, you could go 2 times -2 squared minus 3. 4 times 2 is 8, minus 3 is 5. Oh, look, -2, 5. Right? The nice thing is that everything's there for you. There is multiple ways of getting to the answer. When you're graphing, I want to see at least 5 points on your grid. All right. here's another one. So what do we need to graph? Well, we need a vertex. How do you find the vertex? Think about this being y equals, oh, I hate that it does that, y equals a times x minus h all squared plus k. What is the h value? It's x plus 3, which means the h value is negative 3. Is there anything on the end? Nope. That means that the y value is 0. And if you didn't know that, right, you can also just plug in that negative 3. Like as long as you can determine the x value of the vertex, you're actually good to go. So this would give you 0 squared, which is 0. So this one is going to have a vertex at negative 3, 0, meaning the axis of symmetry is x equals negative 3. Now, if you don't know what else to do from there, just use the table of values. Negative 4, negative 5, negative 2, negative 1. Plug them in, the graph will do what it's going to do, right? We have a vertex at negative 3, 0. What from there? I don't know, right? Plug it in. Or the a value is negative 1. Is the graph going to open up or down? Down. Is it going to be narrower or wider? Nope, it's going to have a normal shape. So I could right away go over 1, down 1, over 2, down 4, over 3, down 9, or I can check with the table of values. Negative, negative 2 plus 3 all squared. 1 squared times negative 1 is negative 1. Over 1, down 1, right? Plug in negative 1. Negative 1 plus 3 is 2. 2 squared is 4. 4 times negative 1 is negative 4. Over 2, down 4. Right? Now I can fit another point. I could go over 3 and down 9 if I'm not using a table of values, right? And you know your shape. And you should recognize that, whoops, I didn't mean to put a 0 there. The shape will repeat on the other side, and then you'll get this lovely symmetry. So again, table of values is totally optional. I never used to put them in, and students were requesting it. They're like, I only understand it with the table of values. I'm like, okay, cool. Like table of values is great, right? So it's whether you like truly understand the shape of a parabola and how you're transforming it, or whether you're thinking, okay, where's the vertex? And then what's the graph going to do from there? Both are awesome. All right, there is one more. So I'm hoping you're at the point where you can pause the video and give this one a go. All right, where's the vertex? So it's x is equal to 6, always the opposite. Think of solving that bracket. And then the y value will be negative 8. Makes the axis of symmetry, x is equal to 6. And I like to plot it. So I've got a vertex at 6, negative 8. And then that goes to the middle of my table of values. And then I can go 2 down from there, and I can go 2 up from there. Unless you understand that because the a value is 3, this graph is going to open up because it's positive, and it's going to be narrower. So if you're okay with the shape, normally I go over 1 and up 1, but the 3 is going to make me go over 1 and up 3. Normally I'd go over 2 and up 4. 4 times 3 is 12. And for some people, this is the one that they're like, nope, didn't understand that. I'm like, okay, do the table of values. This would be 3 times 7 minus 6 all squared minus 8. And you can plug that straight in your calculator or solve it in your head like me because I don't have a calculator. 7 minus 6 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 8 is negative 5. Do I have that point? 7, negative 5. Yes. Then we plug in 8. 8 minus 6 all squared minus 8. So 8 minus 6 is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 8 is 4. I should have a point at 8, 4. Awesome. Now, I'm just going to mirror these over the or over my axis of symmetry, or in your table of values, you'll know it go negative 5 and then 4, whatever works for you, whether you're just plugging in all the values of x or whether you're using that idea of symmetry, but this is my final shape. And there you go, folks. That is how to graph a parabolic function using vertex and shape. Good luck.